All right, here we go. We're getting away from points of concurrency, still working in a triangle. That's what this whole unit is about, sticking with the triangle. I wanted to refresh your memory on a theorem that we went over a couple units ago involving the exterior angle of a triangle. Using this diagram I have up here, can anybody refresh my memory and your classmates to what angle DCA is equal to? Angle DCA, this one right here, what is it equal to? Go ahead, Evan.
Angle CAB plus angle CBA.
Good. All right, those two angles added up. Anybody remember, and I know it's already on the paper, but anybody remember what these are called here again? Remote interior angles. All right, so we all remember that one, yeah? So now I'm going to take it a step above now. Yes, this exterior angle is equal to these two added up. If that's the case, answer this question for me. Which angle's bigger, DCA or angle A all by itself? Why? Well, if DCA is equal to these two added up, shouldn't DCA be bigger than each of these by itself? Yeah, and that's the big thing first half of today's notes, which is any exterior angle is always bigger than either remote interior. All right? So any exterior angle is always bigger than its remote interior. Please do not confuse this. I have no idea what's bigger between the linear pairs. No idea. Do not assume that it's always the exterior. That is not the case. Okay, that is not the case. All right, but I can at least guarantee that this exterior angle right here is always bigger than either of the two remote interiors. All right? Here you go. Let's challenge that theorem now. Here's a beautiful diagram with 8 angles labeled. Can you find me all angles that are less than angle 7? Less than angle 7. And here's your challenge. There are 5 of them. And yes, period 2 found all 5 without any assistance. There's your challenge. Period 2 found them all. Okay, hold on. Hold on. First thing, angle 7 is exterior. So it's got to be greater than any remote interior angles to it. But I will also give you this one and only one warning. Angle 7 is an exterior angle for more than one triangle in this diagram. There should be 5 of them. All right, here we go. Let's go around the room. Let's start with number 23, one angle. Keeping it. 20. We have a winner, angle 4. I just want to show, in case some people don't understand why here. Everyone agree angle 7 is an exterior angle in that triangle I just highlighted? 7 is an exterior angle for 4, which is remote interior. I'm kind of giving away the other angle, but we'll see if anybody says it. Here you go. 7. What's another angle that's less than 7? Angle 5. Same diagram I can use right here, everybody. Take a look. 7 is the exterior. 5 and 4 are the remote interiors. Nice job. Okay, there's another triangle, though, that has 7 as the exterior angle, but let's keep going. Any other angles you found? Number 19. Angle 3, yes. Just so everyone sees, we used triangle LKM, but also 7 is an exterior angle for KJL, where 3 is a remote interior. Good. What's the other remote interior angle there, then? We got angle 3, 20. LKJ, nice job. Everyone agree, LKJ is also remote interior to angle 7. Where's this 5th and final one then? It has nothing to do with remote interiors. All right, it actually has something to do with another fact. Can they do it? Can they get all 5 without assistance? 20, 14. Oh, convenient. 14 is here. Angle 6. I don't remember. The linear pairs, I can't tell. I can't tell with the linear pairs, right? All right, I cannot tell with the linear pairs which one's bigger or smaller. Let's keep going. How about 22? Angle 2, there we go. We got it. Now, hey, let's discuss why angle 2. Well, wasn't angle 7 bigger than LKJ? And what's LKJ made up of? 2 and 4, so it's got to be bigger than each one of those by themselves. All right, 2 and 4. We all good? Anything else? Okay, another challenge. Find angles that are greater than 6. And there's 2 of them. Find angles that are greater than 6. Now we're going inside the triangle. There's 2 of them. Angle 6. Name 2 angles that are greater than 6. You should be saying to yourself, angle 6 is a remote interior for this exterior angle. And there's 2 of them. $16. Find an angle that's bigger than 6. Angle 1, yep. I want to make sure, just in case there's people out there. Here's angle 6. Take a look. Angle 1 is an exterior angle for the triangle where 6 is a remote interior. Everyone see that? There's 1 exterior. 6 would be a remote interior, so 1's bigger. And where's the other angle that's bigger than 6? 3. Oh, convenient. 2. Angle 8. Anybody wondering why 8? Here you go. Angle 8. Exterior angle for... Oops, sorry, wrong triangle. Go back. Go back. Just erase it. Here you go. Angle 8. Exterior angle for triangle JKL. There's 8. Exterior. 6. Remote interior. We all good? Trying to challenge yourself. Which multiple choice is correct there? Read through everything because I give you a little. I give you a pair of congruent sides there that may help you out in that multiple choice problem. Dig deep, honors kids.
1 and 2 have to equal C. I was Okay, so I guess if CD doesn't equal
All right. Here we go. We got some people stuck, which is good. First, start with the given. Where can you go if you know these two sides are congruent? The angles across. Angle 1 is congruent to angle BCA. We're all good there. Okay, so those two angles are congruent. Great. But let's look at BCA right now. Angle BCA. Isn't that an exterior angle for this triangle on the right? So tell me two angles that BCA is definitely greater than. Angle 3, and it's definitely greater than angle 4. Everyone agrees there. Because again, exterior angle, and those two are remote interiors for triangle BCD. All right, well, what did you tell me at the very beginning? If those sides are congruent, these angles are congruent. So what's another name for BCA? Angle 1. I can just substitute that in and say angle 1's got to be greater than angle 3. And angle 1 also has to be greater than angle 4. And that is one of my choices, choice 2. We okay there? I know that was a tough one. How do we feel about that fact? Do we feel comfortable there? Exterior angle greater than either two remote, because I'm going on to a new fact now. All good? All right, I have a huge challenge for you, and nobody in period 2 could do it. Nobody. I got 30 in there, and nobody could do it.
I'm not in period 2, Mr. Yeah, but you're here at 8.
Please,
7.
in both triangles, fill in the missing angle. And then I'll give you 2-3 minutes within your group, find the pattern between the sides and the angles. Go ahead. You do have to find the missing angle first, though. And then see if you can find the pattern, any relationship or pattern between the sides and angles of each triangle.
Oh, wait, right? And then
It's going to be tough unless you know it already, but don't give that away if you already know what's coming up.
I know it's 35.
The sides and the angles. It has nothing to do with multiply this by 2, subtract 5, and you get this. No, it has nothing to do with that. All right. Sides and angles.
Oh my God, it was right now. Is that right? Yeah. Small side. Actually, I got it first. Did you get the pattern? No. Is that right? There's two though. Look at the bottom. Yeah, but I want to know if this one's right. Wait, is it same or the ambiguous is not right? Yeah.
Pattern/relationship. Yes. And it's for any triangle too. I could, it's for any triangle. Okay, we're getting there. I can. We're getting there. Okay, we're there. Yep. Here we go. Pretty. Groups are ready. Groups are getting to it. Everybody, take a look at the first triangle, please. What is the smallest angle in that triangle? 42. What is the smallest side? 4. What is the largest angle? 82. What is the largest side? Where are they located? That is you look back at any of the notes we've done, that is always the case. The smallest angle is always across from the smallest side. Biggest angle across from the biggest side. All right, so there's our new second theorem for today. That will always be the case. In a triangle, the smallest angle is across from the smallest side. And we could fill out number 2, but I got yelled at second period because my number 2 was in a triangle. The biggest side is across from the biggest angle. That's the same thing. Why are we writing that again? All right, fine. I gave up. And I didn't want to hear any more whining. So, all right, but what's that? Okay, I'm not going to write it down. Not going to have you write it down. If you want to, fine. Okay, but in a triangle, smallest angle across from the smallest side. And I know some of you don't like to leave blanks, so that's why I know you write it in, because your OCD is kicking in. It took me a while to get over this, that I'm leaving it blank, but I'm not. This is honors.
Same thing, but I don't want to leave it. Yeah, you can't do that. It was bothering me so much. It's not okay. Like, how really bothered me is like the funniest and everything else I did. Yeah.
All right, we all good there? We'll apply it, and then we'll call it a day. And I got one last honors level question at the end. Okay. Can you please list the sides of each triangle from shortest to longest now, just knowing the angles and our new theorem? So quickly, let's find angle B, because I need to know all 3 angles to compare the sides. Angle B, 92 degrees. And always read the directions carefully. It's shortest to longest. So what's the smallest angle up here? Angle A. What's across from it? Segment BC. Yep. So segment BC is the smallest. Next one is angle C. Across from angle C is BA, making the largest side AC. And now only difference in number 2 is I'm just giving you an exterior angle to deal with. I think we will be okay. What's next to the 107? 73, and then angle T, 32. All right, shortest side then would be across from angle T, so SR. Next one. ST. And then finally, RT. Anything there? All right, a little different. Going to make you do a little algebra for me. Angle A, angle B, and angle C. Which of the following statements is true? Is it isosceles? Is it obtuse? Or is AC or AB the longest side? Well, what do you know about these three angles in triangle ABC? They'll always add up to 180 degrees. So there's a start to finding X and the angles. What are we getting for your value of X? 20, all right. Should be getting 20. Go back to your angles now. If X is 20, angle A, how many degrees? 60 degrees in angle A. How about angle B? 61 degrees in angle B, and angle C? 59. Somebody let me know, why is this not isosceles? I need to have two equal angles to be isosceles. Why is it not obtuse? Got to have at least one angle greater than 90, which I do not. So now it's determined which one's the longest side. Well, which one's the biggest angle? B. And if you want to draw out the triangle, you can. But what side's across from B? A, C. So that has to be the longest side because it's across from the largest angle. All right, ready to finish it on an honors level question. And we're going to make it honors by replacing the word longest with shortest. Which segment is the shortest? All right, well, I can't do anything until what here? Yeah, I need all angles here. I need all the angles before I start making a determination. We getting 57 and 60. All right, let's finish this strong. First of all, directions. It's the entire figure I'm looking for the shortest side. Not the shortest side in each triangle. In the entire figure, which one is the shortest side? So most of us would probably say, oh, it's going to be across from the smallest angle. And I look there. 53 is the smallest angle. And what side's across from 53? B, BD. There's my answer. Sorry, though. Here's why that cannot be my answer. It's the shortest side in triangle BCD, but it's actually the what side in triangle ABD? The longest, which means there's something shorter than that. You see why BD cannot be my side length. So here's how I'm going to do. When you have multiple triangles in your diagram, and I think this will be a lot easier for you to understand whether me just pointing to angles now. What I want you to do quickly in your group right now is to go through each triangle for me, ABD and BCD, and list out the sides for me from shortest to longest. All right? And then hopefully this will be easy for you to determine which one is the actual overall shortest side. All right. Triangle ABD. Can I have number 21 list them from smallest to shortest in ABD? Thank you. How about triangle BCD? Can I get the shortest to longest there? Number 18? Well, I guess it's a battle between these two, right? For shortest side, because those are the shortest sides in both triangles. Why can't it be BD? Hey, look what you wrote over here. Aren't there two sides smaller than BD? So BD overall cannot be the shortest side if there's two more sides that are shorter than it. So now it comes down to AD and BA, and then based on what we have listed here, which one's the shorter one? AD. Yep. So please set those up when you deal with two triangles at once. All right, nice job. Quizzing it tomorrow. I'll check your homework on Friday. I'll be here today if you want to quiz yourself, make some index cards, Quizlet.